Okay, so we've got our hardware made. It's ready to connect to the Raspberry Pi. Let's say we've connected it to the Raspberry Pi. We'll do an example here for pin 21, and we'll just say that our float switch is connected to pin 21, and then we'll move on to the next step in the instructions. Again, the instructions are in the description. So we pick our GPIO pin, connect to the GPIO pin, the float switch to it, connect the other wire to the Raspberry Pi ground, log into the Raspberry Pi using Putty. So we're just going to bring up Putty here, and we'll use the old frag tank Pi that we were working on before. Again, we got our login. We log in with the default Pi as the login, and the password is whatever you made it. I'm not telling you mine because I'm like that. And now we have to create a script in our Raspberry Pi. Now, just a quick note on directories and how they are set up in the Raspberry Pi. When you log into a Raspberry Pi, you're going to see this thing here. Now, you're not actually in the base home root directory of the Raspberry Pi. You're in a directory that is /home/pi. So if I were to go ls here, ls is basically list all the stuff that's in the directory I'm in. You don't see the subdirectory tree that I'm in, but essentially if you wanted to do this, you wanted to see it, we'll go cd / that brings us to the very first base level point in the operating system file system. And if we go ls here, it's going to show us subdirectories that are in there and files, which there aren't any. Like I said, we are in home here, so we'll go cd home. We put everything in the home, we put everything in the, and here's the other directory, pi, oops, cd pi, and we are back. So this is the directory we pretty much put everything, because that's the directory we're logged into by default. So it's easy just to put stuff in there, if you care. That's just a little programming operating system tip. So to create our script to give our float switches the pull-up resistor functionality on these pins, we're going to use a program called Nano. It's the same program we used before to add a little scripting to our system. So it's the same thing. The other thing we want to do with these float switches is we want to give them a delay timer of, I'm using 10 seconds to read the actual switch. So what happens with switches sometimes is you get this thing called bouncing, which means there's a little bit of current bouncing in between the switch and the Pi, which can kind of throw off the reading of the switch. To alleviate that problem is we add a little timer to the switch saying, okay, Raspberry Pi, check the switch out every 10 seconds to see its state. And if it's the same way throughout that 10 seconds, then that's the state. So that kind of, it gives us a little bit of fail-safe against current or voltage bouncing, whatever you want to call it, and it works. I had a problem with this at the beginning, so I just figured out how to do this. So to make the script, we're going to go sudo nano float 1.py. Pi stands for Python. We are creating a Python script. Now I've gone ahead and done that. I've put the information in this script, and the information, the code is in the description of the video here, and this is it. All you have to do is copy and paste it. But what you have to do is, if you paste it in, remember it's right click copy, come over here and then right click and it'll paste automatically. But what you need to do is you have to make sure that the spacing is exactly right. So anything with a number sign is just a comment. So that's not actually programming code. It's just a comment for housekeeping's sake. This is where the programming starts. Import the GPIO library, import the time library. This gives your script the functionality to do these things and control these things. And then this is where it gets kind of into what you decide to put in the script. So what we're saying here is the setup on pin 21, where we connected the one wire from the float switch, is going to have a pull-up resistor. Now you could actually add a pull-down resistor. You would just have to change the upward to down. So what we want is a pull-up resistor, and what we're going to say after that is, while the input state is false, I know it sounds a little counterintuitive, but we're going with false, that we can also print a comment in the Raspberry Pi saying the auto tank is filled. That's just for my own sake, for checking to make sure that the script works. I suggest add something like that, because you'll use it later on if you want to check that the script is working. I'll show you a couple ways to make sure the script is working. And then the time sleep 10, this is 10 seconds, gives it that, like I said, that kind of security against voltage bouncing on the switch, so your Reef Pi works properly and it's not accidentally filling your system all the time when it shouldn't. So when you're done putting the script in like this, so we've got, this is a new line, this is a new line, this is a new line. There's no spaces at the end of these. You got to make sure of that. This is a tab here, a single tab, and this is a double tab. And then we've got our everything here on a new line. So you got to make your script look like this, because in these scripts spacing matters. So when you're done, Control X, you'll get a prompt to ask you to save it. Press Y and hit enter, and it'll save it. So now what we got to do is we got to put this script that we just created in the startup of the Raspberry Pi. So say if the Raspberry Pi shuts down for whatever reason, there's a power outage or something like that, we have to make sure that this script runs every time that the Raspberry Pi starts up. So to do that, we're going to enter it into a file called the RC local file. That's a file that the Raspberry Pi looks at and says, okay, what do I need to do? Is there any commands here for me to run when I start up? So we're going to type sudo nano / that file is in the etc directory, rc.local. Bam. So this is what it looks like. Now you'll just scroll down, use your arrows, go down to the bottom, and just before exit, add this line python / home / pi, which is the location of our float1.py Python script. Hit Control X, hit Y to save, and you're done. That's it. So now whenever you restart your Pi, it's going to be loaded automatically. To test to see, now at this point I suggest you do a sudo reboot, if you do it in the, in the right place. There we go. Sudo reboot, and then log back in. You get the idea. Then type this script down here to make sure that it's running properly. ps-aef line, whatever it is, grep, and it will show you if it's working properly. It will say the name of the script and that it's running. If this doesn't show up, if nothing shows up, it means that your script isn't running properly. You need to go back in and you need to check the spacing. If you want to find out what line the error is on, you're going to enter this code, the Python float 1.py. Now after you type this, it's actually going to pump you into that Python script. So then you'll have to usually shut down Putty and restart it just to make sure it's going. So if you hit that and nothing happens, or your float switch starts sending a command saying like fill the auto top off tank, that means it's working. That means it's working. Or it's going to pump out an error message saying error line whatever. Then you go back in, take a look at it. It's probably a spacing issue. You fix it and you come back out and you just kind of sort it out that way. That's a little way to problem solve it. Right now that's working. So now we have to go over and we have to set up the float switch in the Reef Pi. So